Hello, pre-calculus class. In this video, we're going to take a look at one last property of logs that didn't really fit well in with the last three properties. Those kind of all go together. This last one is a little bit of a standalone, something called the change of base property that lets me change the base of a logarithmic function to whatever I want it to be. So we're going to derive that change of base and see maybe an example or two of how you might use that in the textbook. So we're going to take a look at just an example to kind of get us through this. Let's say we had some value of x, some unknown, that was equal to the log base 7 of 500. Okay. Now we have calculators that will let us find that, right? Like I could go into Desmos and it has a change of base, like it has a base button for logs, and I can find what is the log base 7 of 500. Not that long ago, that was not an option. You didn't have a base button for these logs. You would have to change this base to something else, like the log base 10 or the log base e, in order to solve what this was. Like even just like a TI-83 calculator, right? The standard for, I don't know, like only 4 or 5 years ago, does not have a log base button, and even some of the TI-84s will not have that change of base button either, right? So we could solve for this by changing its base by doing just a little rewriting. So we have this thing, right? Again, this, if I have this, this is my logarithmic form, right, of an equation. But everything that I can write as a logarithm, I can also write as an exponential. So I want to rewrite this. Right? Very key thing is getting comfortable with rewriting things from logarithmic form to exponential form and vice versa. I want to rewrite this in exponential form. So this, if I wanted to rewrite it in exponential, 7 is my base, x is equal to log, so x is the exponent, so I'd have 7 to the power of x would be equal to the answer. I'm looking for what is the exponent and the power of 7. That would give me 500 as an answer. These two things are equivalent to each other. So now if I wanted to solve this, I could take the log of both sides. If I wanted to get x by itself. It's an equation, it's balanced, and whatever I do to one side of the equation, as long as I do it to the other, it will stay in balance. So I want to take the log of both sides. So I would get the log of 7 to the x is equal to the log of 500. Now we have this left side here, the log of 7 to the power of x. That is just like my power property that we had before, right? That if I have the log, right, use this power property of logs, that says, right, log of x to the y is equal to y times the log of x. In this case, my x and my y are kind of switched here, but I could take this exponent and put it out front. I could rewrite this as x times the log of 7 is equal to the log of 500. Right? And now I just have x times the log of 7 is just a number. If I wanted to get x by itself, I'm multiplying it by a number. To undo that, I would have to divide by that number. So just divide both sides by the log of 7. I end up with x is equal to the log of 500 divided by the log of 7. Right? But we started off by saying that x was equal to the log of 7, log base 7 of 500. So now I know that there's an equivalent expression here. The log base 7 of 500 is equal to the log of 500 divided by the log of 7. This let me change the base from 7 to, in this case, it's just base 10. It would not have to be base 10, right? Up here, I could have just as easily taken the natural log of both sides. Again, as long as I did it to one side of the equation and did it to the other side, it would be the same thing. So this could have been ln of 500, ln of 7 to the x, and divided by the natural log. This is true for any base a. Right? It would not have to be base 10. Right? So let's just double check that with the calculator, show how that's true. I'll bring this in a little closer here so I can zoom in a little bit more. But if I had log base 7 of 500, gives me like 3.19 something. If I did the log of 500 and divided that, let's put this in parentheses here, divided that by the log of 7, I would get the same thing. Would also work if I did the natural log of 500 divided by the natural log of 7 would give me the same. I could do log base 2 of 500 divided by the log base 2 of 7. It's the same thing every single time. So I get this change of base formula, change of base property. That I can generalize. That the log base a of x is equal to the log base b of x divided by the log base b of a. Okay. This is true for any b, right? Oftentimes we'll choose that b to be 10 if I'm trying to go from one way to the other, but it's true for any base at all. So let's look at a quick example of how we might see this. Right. If I had like the log base 8 of 27 divided by the log base 8 of 3. Right. Well, the log base 8 of 27, just looking at that numerator alone here, right, this is trying to find what is the exponent in the power of 8 that would give me 27 as an answer, right? And that's going to be some pretty ugly thing here. Right? If I tried to evaluate that, I got the log base 8, log base 8 of 27. It's not a very nice number. It's kind of this irrational number, probably. And the log base 8 of 3, same thing. It's looking for what's the exponent in the power of 3 that would give me, right, or the exponent in the power of 8 that would give me 3 as an answer. It won't let me change that, but yeah. But if I wanted to, right, oops, log base 8 of 3, I could change this base. Say this going, I have this on the right hand side now, and I could change it to the left hand side, where my x is 27, and my a is 3. So the log base 8 of 27 divided by log base 8 of 3 is the same thing as the log base 3 of 27. And now this is saying what's the exponent in the power of 3 that would give me 27 as an answer? Well, 3 cubed gives me 27 as an answer. So I could do log base 8. Come on. Log base 8 of 27 divided by the log base 8 of 3 gives me 3, because it's the same thing as doing the log base 3 of 27. So I could also do it, right? This is the same thing as just doing the log of 27 divided by the log of 3 would also give me 3. The natural log of 27, nope. Right. The natural log of 27 divided by the natural log of 3 would also give me 3. They all mean the same thing because they're all coming back to this basic meaning. So there's change of base in a nutshell.